Alright, so I wanted to show you another program. This one is a little complex. I've tried commenting it here as much as I could to explain what's going on. I'll also post a link to this so you can play around with it. But I wanted to show you um, with scaling text, creating sort of a drawing program where we can change the size dynamically depending on the speed of the mouse. We can also change the color and have the text rotate as we move it around the screen. So I'm just going to kind of run through the text here somewhat quickly to give you kind of an overview of what's happening, and then we'll see it in action. So here in the beginning, I'm just initializing some variables. I have a float for an x and y, and it's just going to be where we end up where we're going to store the letters, the position of where we're going to put the letters. I also have a variable called kerning. I just give it here just an arbitrary number to start, but we're going to be able to determine, depending on the text size itself, how much space we need in order to write the next letter. Here you're familiar with this. We're loading our font. I'm again creating a string with some text, and I'm just putting a little statement within that. And that's the text we're going to use to draw. Those are the letters we're going to draw to the screen. I have a few more variables here. I have a font size minimum, so the 3 is just the smallest the text can go, just so it's still legible on the screen. There's no need for it to go to 0. And I have a counter here, and it's set to 0. It's just sort of generic. Towards the end of the program, you'll see that the counter will get updated by 1, and we're using that value to move through this string. So a string is a sequence of characters, and we can kind of count starting at 0, which would be the C here. We can kind of iterate through each one of the letters and spaces. So setup, I'm using something different here that perhaps you haven't seen before. The display width and display height. And what this does is just captures a full screen window. Depending on your output source, what type of monitor you're using. On my laptop, it just picks that resolution. Background is being set to 255 to start. And here's another thing perhaps you haven't seen. I'm just changing the shape of the cursor to be a cross. So when we're drawing with it, it's just obvious of where we're placing the cursor, because we're going to activate this program by using the mouse pressed function. So here's my font. I'm using the create font here again, not the load font. This is going to make the scaling much better as we sort of dynamically change the size of the text. I'm just setting it to 25 just as a generic, just to get things going. Text font, loading it, just one of those necessary steps. And then I'm using an alignment of left. So I'm specifying that. Okay, so that's the setup. So that stuff gets run once, and now we get into the dynamic part, the draw function. So I started with this conditional statement, the if statement, wondering about the mouse being pressed. Now I also down here at the bottom have this function, void mouse press. And here this is going to just keep track of where the mouse is. And so we're just loading the mouse X and mouse Y into those XY variables. So that's going to be where we start drawing the text. So it's only when the mouse is pressed. So every time this starts, it'll know to start the text where we're clicking, where we're pressing the mouse, instead of where we left off, wherever we released the mouse previously. Okay, so it's going to put those values into the X and Y, and that's going to be where it knows where to put the letters. Those are the variables X, Y. So the first thing I'm going to do in this if statement, once we said, all right, the mouse is pressed, the X and Y is now filled with the mouse X and mouse Y coordinates, I'm going to determine a distance. I'm just using a variable called D and a float, and I'm using a distance function, so I'm just calculating the difference between, so right now, the first time it would essentially be 0, so right there on the same spot, but as we're moving, this X and Y is going to get updated. Okay? So it calculates the distance between current position and where the mouse is. I'm going to use a fill function here, and I'm using that distance to fill in the red channel. So the greater the distance or the speed that the mouse is moving, the higher that value will be and the greater the red channel will get affected. Text size, we're going to do a similar thing. This is just a little scaling feature here, so I'm just taking that minimum size, the 3, and I'm going to add that distance and just divide it by 2. I can make different numbers, but I'm using that just to keep it so it only gets so big as well. I don't want it to like take over the screen and be gigantic. So here's a character. The next thing I want to know is what letter do I need to put on the screen. And so I have a character variable. I'm calling it new letter. And this is a little strange here. I'm sorry that this is a little advanced, but the text here is the variable that we used for the string. So all the way back up at the top, we have this string text. And since this is capitalized, we talked about these being classes. It's still a variable, but kind of like the P font and other things, the capitalization means it's a class. So within a class, we talked about in the lecture here, this sort of cookie analogy, we have different methods. There's different functions that we can use that are specific to this class. And we access those through this sort of dot terminator or dot syntax mode. So that's why there's a dot here, and then this is a function that I'm adding specifically to that variable, that string class variable. Okay, so this is just going to determine what character, so it's going to pull out each individual character based upon the counter variable. So it starts off at 0. So essentially the first letter, the new letter that it's going to write, is going to be the first character that it finds. Now the counter will keep getting updated, so we'll just keep going through all of the different characters within the string. Okay. Here I have the kerning variable. I'm setting it to using the text width function of that new letter. So it takes the new letter, it says, all right, what character is it, and what is its width? It returns a value for that. And I'm just using it in a float just to be a little bit more precise with it. Okay? So those things are determined. Now, once we have kerning and a distance, we're going to use another if statement here, and we're just going to give ourselves space to write the letter. So we want to find out when the distance between the last letter and the mouse is greater than the space needed to write the letter, because I don't want the letters to overlap each other. I want each letter to be recognizable. So I want to know when that distance is greater than the space required to write the letter into it. So that's why I have this if statement here. So when that's true, I'm ready to write a letter or a character at that XY space. I'm also going to determine the angle. So this is a weird trig function, and the this atan2, it just finds the x and y position, or it finds the angle of the x and y between 2 points. It essentially finds the angle between 2 points. So the x and y of where the text is and the angle that my mouse is at, just so it's going to rotate the text to kind of follow that path. So you can look more into the reference on the atan2. What's weird about it is that the y coordinate comes first. It's just how this trig function works. It just wants that value first. So usually it's xy as a convention for us, but this is the one time it switches over, and I'm just subtracting the x and y position from it to get that angle from it. Okay, so that'll give us an angle to rotate the text. Now again, this is getting kind of weird, perhaps. These are transformations. When we get into motion next week, you're going to see a lot more of this. But essentially, it's like drawing on a piece of paper. And if I put another piece of paper on top of that paper and I start drawing something on top of that, and I move that paper around, I can still move it around the screen. The shape itself isn't moving, I'm moving the coordinate system. So that's what this push matrix is. It's basically going to say, the push matrix always has a pop matrix, and the push is going to say, all right, get ready to move it, but know where to go back to. So now I'm stacking a piece of paper on top of it. When I do the pop matrix, it throws that piece of paper away, so to speak. The translate is what's going to move it, so it's going to move it x and y. It's going to rotate it by the angle that we've given it from the this trig function up here. And now finally it's going to write the letter. So here's the text function. It's going to write whatever the next letter is. And it's going to write it at 0, 0. So that's actually at the coordinate origin. That is the top left of the screen. So since we're using these sort of matrix functions, the translation is going to move that 0, 0, that top left corner of the window, around to this position, to the x and y. So it's always going to be, the letter's always going to be at 0, 0, but the translation is going to take care of the positioning of it. Instead of trying to put dynamically variables in here to do it and keeping track, it's just easier to do it this way. And then the pop matrix pops it back to the 0, 0 until we're ready to write a new letter, and then that will move it and we'll update the x and y. And we'll do that here coming up. The next thing we're going to do, though, is we're going to update that counter. We're just going to update it by 1, and we're going to have a little catch here. So we're going to say if the counter is greater than, here's another sort of method you can put to this sort of text variable. I'm going to look at the length and -1. So it's the length that starts at 0 and it moves through. So I'm doing the -1 just to catch the last letter and not to go beyond it. So if the counter is greater, if it exceeds how many characters are actually in the string, it's just going to reset itself back to 0 and start again. So it'll just kind of loop itself through all of the characters continually in that string. And then we're going to update our x and y position. So the x is now going to equal x where it was plus the cosine of the angle. So cosine is a good way to find x position. I don't know trig very well. These are just things that I've learned in coding. So these are just things you use. So I'm going to take the cosine of that angle. I'm going to multiply it then also by that letter spacing. And I'm going to do the same thing with the sine. And the sine will give us the y coordinate. Okay, so it's just going to update our x and y coordinates. It's going to give us the new place to write the next letter. And so now you've suffered your way through all of this explanation. Let's actually see this at work. You're going to see this really large window size. And you see the cross cursor. And once I start drawing, I'm going to start drawing letters to the screen. And they're going to follow the mouse. They're being a little slow. I think from the screen recording, it's going to seem a little slow. So you can see that the color changes, the size changes. Let me see if I can make one really small. So really small and then really big. Okay? So we're just drawing with different letters. You can see they rotate and they move around. Again, I'm going to put this code and make it available for you. You can download it, or at least it'll pop up in another window and you can copy and paste it into a processing editor and hopefully run it yourself and play around with it and see what you can do.